Hey guys, in this video, I will show you how to use Microsoft Visual Studio to create data cube based on the data warehouses and perform quick and easy data analytics. So the goal of this video is to show you how we can use the mouse drag and drop like this to select measures and, for example, month name. Okay, to quickly perform data analytics without writing any SQL queries. For another example, let me delete what I have here. Okay, so for another example, for each student, calculate their total assignment submission count and also the aggregated score for each student. Okay, you can also break down these data by, say, for example, the hourly bucket in a day. Okay, so how each student submitted each assignment over different time of a day. Okay, so we can perform this kind of analytics by only using mouse drag and drop from this drop-down list, okay, without writing any codes or SQL queries. Okay, and the software I'm using for this video, so here is the list. So I'm using SQL Server 2022 Developer Edition with Analysis Service extension installed. So you have to do the custom installation to make this happen. And I'm using SQL Server Management Studio as my client application. Okay, so the implementation of the data cube analysis was done by using Visual Studio 2022 Community Edition. And I also installed Analysis Service extension in it. If you want to link the data cube analysis results into Excel, for example, like you want to perform pivot table analysis, then you can also have a Microsoft Excel downloaded. Okay, so I have installed all this software in Amazon EC2 environment, and I also have a video showing how to register and launch an Amazon EC2 instance and how to install this software in it. If you haven't done yet, please refer to that video to get this done. Okay, and the data sample, the data warehouse I'm using for this video is called Student DW, which has 5 tables designed in a star schema structure. So this structure has a one fact table, one fact submission table that has several foreign keys pointing to other dimension tables, and it has a score as numerical measure attribute. And to support this fact table, I have 4 dimension tables, including the assignment dimension that provides a list of assignment IDs, their names, and their due dates. The student dimension is the second table, which has a list of 6 students, their IDs, first name, last name, age, and GPA. And further, I have a date dimension, which has a detailed information regarding each date included in this assignment submission records, and a time dimension, which also has a detailed information regarding every single second in a day. Okay, so this is the prerequisite to perform data cube analysis in Visual Studio as demonstrated in this video. I also have another video showing how to create the student DW data warehouse using the ETL script that I designed in a previous video that I posted. So if you haven't prepared student DW data warehouse, please check that out. Okay, so let's get started. So after you start the Visual Studio, you need to create a new project. And the type of the project that supports the data cube analysis is called analysis service multidimensional project. Okay, so this is enabled by the analysis service extension plugin for Visual Studio. If you don't have it, you need to download and install that extension. Okay, so we can give it a project name such as student data cube. Yeah, student data cube, for example. Then hit create. Okay, so this will create an empty template for you to start the exploration of data cube analysis. Right, so which basically gives you a list of folders to configure in this Solution Explorer pane. Okay, so the first step here is to right-click on the Data Sources folder and select New Data Source. Hit Next. Okay, so here we want to create a data source based on existing or new connection. Okay, so please switch to create a data source based on existing or new connection and hit New here. Okay, so it was saying the specified provider was not supported because the default provider native OLEDB needs to be changed. It needs to be changed to Microsoft OLEDB provider for SQL Server. Okay, so please don't forget to change the provider to Microsoft OLEDB provider for SQL Server. Okay, and then you can hit this button to search for the available server on your computer. Okay, so in my case, I have installed a software and I'm hosting my student DW data warehouse in Amazon EC2. So this will help me automatically identify the name, okay, server name for my Amazon EC2 server. Okay, so on the log on to the server option here, please switch to SQL Server authentication and enter the username and the password. Right, so here we want to use the user who prepared or say who created the student DW data warehouse. Okay, so what do I mean? So you can check the owner of this student DW in SSMS by right-click on the student DW data warehouse, select properties, okay, and check this column. Okay, owner of this database is SA. Okay, SA stands for system admin. So I was logged in as system admin, and I created the student DW under this SA login credential. Okay, so this is the login name and the password I need to enter here. SA and my system admin password as the SQL Server authentication credentials. Okay, so after you have filled up to here, you can click the test connection button to see whether this username and password was entered correctly. Okay, test connection succeeded, so that means I can move on. Okay, so connect to a database. Select or enter a database name. So here you need to select the student DW or whatever data warehouse that you have prepared in the star schema format. Okay, so that become my existing connection. Hit next. Okay, in the impersonation information step, we want to use the service account rather than the Windows username or password. Okay, because we want the Visual Studio to be able to access the Microsoft SQL Server. Okay, so it counts as a service account in this purpose. Okay, hit next and finish, so that a student dw.ds, the data source, will be created here. Okay, so that's the step number one. Step number 2 is to configure the data source views. So again, we can right-click on data source view folder and select new data source view. Hit next. Okay, and select the student DW data source that we just created and hit next. Okay, select tables and views. So in my case, my student DW only contains one star schema represented by one fact table and 4 dimension tables. But when you perform data cube analysis, and if your data warehouse contains more than one star schemas, you want to select which set of tables consists one star schema. Okay, but in my case, all of them count as one star schema, so I will just select all of them and hit next. Finish. Okay, so now we have a student DW data source view. The next step is to create data cube. Right-click on the data cube folder, select new cube. Next. Select creation method. So I'd like to create data cube using existing tables in my data warehouse, student DW data warehouse. Hit next. Select measure group tables. Okay, so this step is asking you which of these 5 tables is the fact table. Okay, because the fact table is the one containing the measurable facts of the data warehouse. So we'll choose fact submission table as the measure group tables. Hit next. And select all the available measures in the fact table. Hit next. Okay. Then all the remaining tables are my dimension tables. So they are all selected. Okay, finish. Okay, so now you can see that data cube has been generated under the cube folder, and 4 dimensions are also created under the dimensions folder. Okay, and it also automatically generates a star schema representation of your data warehouse, where I have one fact table and 4 dimension tables surrounding it. Okay, so in order to browse this data cube, we can right-click on studentdw.cube. Okay, but before we can browse it, we need to process it. Okay, processing it means deploying the data cube on the server. Okay, so this will open up a process cube window looking like this. Okay, so when you see this window, you may want to scroll down to the bottom of this window to find this run button. Okay, so we need to click this run button to process it. Okay, so please wait until the process succeeded message is showing up, and you can hit the close button. Okay, close it. And now we are back to the main interface of the Visual Studio with a small floating window saying the deployment completed successfully. Okay, so now your data cube is ready to be browsed. You can right-click on the data cube again, and then select Browse. Okay, so if this floating window says knowing, we can just close it. Okay, so before we can see anything, we need to hit this refresh button to show this interface. Okay, so now we can select the measurable fact from the measure groups, for example, submission count, okay, combined with other attributes available in the dimensions such as student ID. Okay, we can use this drag and drop methods to quickly perform analysis, analytics like this. Okay. But by default, as you can see, the only available attributes in those dimensions are IDs. date key, assignment ID, this kind of stuff. Okay. So this is not good because these ID values are not very intuitive to human readers. Okay. So in order to provide more attributes available for our analysis, we need to edit the dimensions in the dimensions folder. Okay. So for example, we can right click on the dimension student, select view designer. Okay. So this is where we can decide what attributes we want to incorporate into data cube analysis. Okay. So for example, we can drag and drop the first name, last name from the data source view panel into the attributes panel on the left hand side. Okay. We can also do GPA and age as well. Okay. Just choose whatever attributes you want to incorporate into analysis from this here to attributes section here. So similarly, we can also edit the assignment dimension for another example. Okay. Drag and drop assignment name and the due dates in here. Okay, so this happens to all the dimensions. However, if the dimension like date has too many attributes to analyze, I mean, we don't have to analyze all of them, right? Okay, we don't need to analyze the day suffix, day of week, USA, UK, this kind of slight difference in most cases. Okay, I mean, not always, but in most cases, we don't need them. Okay, so we only need to select the attributes that we want to incorporate into the data cube analysis. So for example, if I want to analyze how month name and the submission count relates, okay, the month name like January, February, and so on. Okay, for another example, I also want to analyze the day name. Okay, the day name. Okay, I can drag and drop the day name from here into here. Okay, the day name is like Monday, Tuesday, Wednesday, Friday. Okay, if I want to analyze the weekday versus weekend analysis, we can find such corresponding attributes if weekday into the attributes. Okay, so how do you know what is represented by each attribute in this dimension? Okay, so when you have this kind of question, you can go back to the original data warehouse and take a look at the content of the data dimension, for example, okay, where you can find the meaning. You can see the meaning of each attribute, such as day name, okay, such as month name, quarter name, and so on. Okay, so this will help you decide what attributes you want to drag and drop from here into the attributes section. Okay, so finally, I will choose the hourly bucket and daytime bucket from time dimension into the attributes here. So after you finish editing all the dimensions, we can update our data cube. Okay. But before we can browse it, we need to process it again. Okay. So just repeat the previous demonstration to right click on the cube, select process. Okay. Run this process the code by hitting the run button at the bottom. Okay, wait until you can hit the close button, okay, to redeploy the data cube onto the server. Okay, and then you are ready to browse the cube by right-clicking on the cube file, select browse. Okay, sometimes it's a good idea to just close all the tabs and browse it. Okay, refresh it when you see nothing. Everything will be back. Okay, so now we are ready to perform submission count analysis, for example, by student first names rather than their IDs, okay, which is more intuitive. And we can also calculate the aggregated assignment score from these 12 submissions each student has made. For another example, we can also drag and drop count versus the daytime bucket, to see the submission count made during different time of a day, like this. Just one more example, we can perform month name, drag and drop month name and submission count to see the breakdown of the submission count based on different months. Okay, so this is basically how we can use the Visual Studio to perform data cube analysis. Okay, so furthermore, we can also link the data cube to Microsoft Excel. Okay, so you can see a green button located here. So by clicking the button, you will enter the Microsoft Excel. Okay, and in Excel, it helps you to use the pivot table feature here to perform similar analysis, but with more convenient features. So for example, I can also choose submission count and daytime bucket here, okay, to present the results in spreadsheet. So personally, I think this is more good looking. Okay, for another example, we can also perform multi-dimension analysis by choosing one attribute from time dimension and another from the student dimension. Okay, so this can also support expansion and collapse. Okay, on different time of the day, how each student were doing their submission count. Okay, so we can basically just choose whatever attributes we want to incorporate in the analysis from this drop-down list. Okay, and we can also adjust how to display the results in the most aesthetically good way. Okay, for example, I can drag and drop the first name into columns rather than in rows, so that I can display them in a matrix, the student versus daytime bucket matrix, to show the breakdown of the submission count during different time of day by different students. We can also adjust the display, like swapping the first name with daytime bucket, okay, to find the best way to present the data. Personally, I think this is worse than the previous. Okay, it's worse than this. And just one more example. Okay, I can analyze the submission count and score at the same time, for example. Okay, so, but let's put the first name on rows. Okay, so now we have a list of students, their submission count and aggregated scores from these 12 submissions. Okay, so sometimes this aggregated score doesn't make sense, doesn't make too much sense. We want to, for example, calculate the average score for each student. So we know how to use the formula. Okay, I think you know how to use the Excel formula. This equal score divided by this, okay, to get the average score for each student. But problem is when you extend the formula like this, okay, it doesn't actually extend. Okay, it only extends the fixed value from the first row, rather than calculating the average score for each different student. So this is because, I don't know the exact reason, but it's because of the usage of pivot table in an incorrect way. Okay. So the way I overcome this is, usually I will just copy the whole table here and paste the values only. Okay, paste the values only version of the same table in a different place in the spreadsheet, and then repeat. Okay, repeat the formula adjustment and extension, okay, to get the work done. Okay, so cannot be done in the Visual Studio Data Cube here, but this is enabled in Microsoft Excel, which is pretty handy to me. Okay, so that's it. So in summary, this video showed you how to use these software, especially SQL Server 2022 and Visual Studio 2022. Okay, we can build a data warehouse in SQL Server, then connect it to Visual Studio to create data cube and perform the data cube analysis. Okay, we further showed how to link Visual Studio to Microsoft 365 Excel to utilize its pivot table features. Okay, so hope you enjoyed this video, and thanks for watching.